Let us continue solid state. In the solid state, we will see close packed lattice. In the close packed lattice, we will see in the close packed lattice we are seeing voids. We are seeing which void in the sense octahedral void and tetrahedral void. Now we will go for octahedral void. For going for octahedral void, first we will take one layer. In one layer we have considered. So three particles we considered here. These three particles, how it is there means these three particles, how it is there. These three particles arranged in a triangular manner. These three particles arranged in a triangular manner like this. Okay. So in this triangle, at center here, if you see empty space is there. This we will call it as interstitial void. Interstitial void we can call. Interstitial void we can say. Then second layer we will take. In second layer also we will take a triangle. Okay. In this triangle also, here what is there means empty space is there. So in this triangle empty space is there. Okay. So in this triangle at center point void is there. In this triangle at center point void is there. Now how to keep means keep one layer over another layer. Okay, such that these two triangles are opposite to each other. Okay, suppose this triangle like this means keep this triangle like this opposite way. Now keep one over another. Okay, you are keeping one over another. So two triangles you kept one over another like this. Okay, so you have placed two triangles like this. Okay, so one triangle suppose you are taking like this means if you take like this means another triangle take opposite to this. So take opposite to this like this, you have to take another triangle. So two triangles you have to keep one over another. Like this you have to keep two triangles. Okay, sir, if you keep two triangles like this, how the void of this triangle and void of this triangle will be there, do you think? If you pass the axis, that two voids, how it will be there, do you say? Now this is one triangle, here center point void is there. It is another triangle, at center point void is there. These two triangles we will keep like this. Okay, we kept like this. Now how the voids are there, see how the voids will be there, you see okay, how the voids present, you see that. So shall we say that this is pausing like this is pausing, you see that how the voids present, you see how the voids. Shall we say that will this void present in this second layer, it's below first layer void is there, shall we say? This void present in this layer, this void present in this layer, we will keep two triangles opposite to each other like this. Okay, this is second layer will take, it is first layer will take. This void is present in second layer, below that first layer void is there, or what do you say? For this we will take this broomstick and we will pass broomstick like this. Now see, broomstick comes like this. So we will keep broomstick like this. Then shall we say that here void is present in the second layer, below that first layer void is there, shall we say? Sir, okay. Now we have taken this two triangles we have taken. These are two layers. We can say. These are two layers. Now, what is the shape of this one? That we want to say it. What is the shape of this one? Now, to say that shape, now we will take these two layers like this. Now, in these two layers, this is this if you say, if you join these three, in this layer, if you join these three center points, what shape you will get, you think? In this layer, okay, in this layer, if you join these three center points, will you get a triangle, you think it? Sir, then we'll see this layer, we'll see this layer. we'll see this layer. Okay, now we will see this layer will take. Now we will take this layer. In this layer we are taking these three particles. In this layer we are taking these three particles. If we join these three particle center points, if we join these three particle center points, will you get a triangle? If we join these three spheres of this layer center points, will you get a triangle? Okay, so one triangle in this layer, one triangle in this layer. Okay, so this layer is one triangle, this layer is another triangle. Okay, this is first layer means one triangle, it is second layer means another triangle. So using these two layers, we got two triangles. Now we will keep one triangle over another triangle in a opposite manner. We will keep, sir, we placed opposite manner. Using two layers, do we get triangle? That we'll see. Using two layers, do we get triangles? That we'll see. Using two layers, do we get triangles? That point we'll see. Okay, so now you take in this layer one particle, you take one particle in this layer, take two particles in the above layer. Okay, in this layer one particle you are taking, above layer you are taking two particles, join them, below layer one particle, above layer two particles, join them. What you are getting? From here to here to here to here, join these three centers. Are you getting a triangle? Okay, sir, next what you have to do means, above layer one particle, below layer two particles, above layer one particle, below layer two particles, you take like this, you join their centers. Okay, so below layer two particles, above layer one particle. Now we will join their center points. From here go to this center point, go to this center point, come back to this center point. Is it a triangle? So like this you have to do in the first and second layer. In between these two layers, how many triangles will be obtained? That you think. So what you have to do means, below first particle you take, above two particles you take. Okay, below one particle, above two particles. If we take one triangle, then neighbor, above one particle, below two particles. If you take one triangle, that is two. So now you see, this will give triangle with these two, and this will give triangle with these two. Correct? So it is giving how many triangles is it is one, here two, so one triangle. Below two, above one triangle. So if you see like this, between first and second layers, how many triangles we will get? How many triangles we will get? How many triangles we will get, do you think? So using this below one, above two, one triangle. Below two, above one triangle we said. So two triangles we said. For this, using this one, we said two triangles, no? Now using this, can we say two triangles? Then using this, can we say two triangles? So now see, using this we said two triangles. So using this, can we say two triangles? Using this, can we say two triangles? Then using this, can we say two triangles? So shall we say totally how many triangles using these two layers? So using these two layers, how many triangles we can say? Shall we say six triangles? So using these two layers, we are saying six triangles. Then one triangle at top triangle I will show this, and bottom triangle, that I will show bottom triangle, bottom one triangle. So totally how many triangles? How many triangles we are getting? 8 triangles we are getting. The triangles are which triangle? Which type of triangle? Equilateral triangle. So how many equivalent equilateral triangles we got? Totally 8. Totally 8 equivalent equilateral triangles we got it. So 8 in the sense octa. Equivalent equilateral triangles, therefore hedron. So octahedron. So what is the shape we are getting from this? We will get a octahedron. We will get it. It gives what means octahedron. It gives octahedron. So in this in the octahedron means at center of octahedron here, at center of octahedron. Okay, so here in this place center of octahedron means this. Okay, center of octahedron means this place. Center of octahedron means this place. At center of octahedron, is there any void? That means at center of octahedron means what is the meaning? Means it is octahedron. We came to know it. At center of octahedron means you see here. You see here. Okay, this place. This place. Is it a void? If that void is formed in where? Formed in where? Formed in octahedron. That void is formed in octahedron. So that void is called what? That void is called octahedral void, we can say. That void we can call it as a octahedron void. Okay, so octahedral void. What is meant by octahedral void? You got an idea? So to get octahedral void, how many layers we have to take? We have to take 2 successive layers. To get octahedral void, we have to consider 2 successive layers. Sir. So 2 successive layers we considered. In that successive layers, what we have to do means in one layer you take one triangle. In another layer you take another triangle. Keep these two triangles in a opposite manner. Sir. So if this triangle like this means we will take this triangle like this. So we will keep two triangles opposite manner we placed. We placed two triangles opposite manner. Then we are getting what means octahedron we are getting. So in this center of octahedron, in the center of octahedron, what is there means octahedral void is there. At the center of octahedron, what is there means octahedral void is there. Now octahedral void, this octahedron, now octahedral void, octahedron we got. To get octahedron, how many particles you have to consider? Here 3, 6. So in the octahedron, at the center of octahedron, what is there? Octahedral void is there. That octahedral void is in contact with how many particles here? This is the octahedral void, correct? This octahedral void is in contact with how many particles? That octahedron void is enclosed by how many particles? That octahedron void is enclosed by how many particles? Octahedron void is in contact with how many particles? That you see. Shall we say octahedron void is enclosed by these 6 particles? Octahedral void is in contact with these 6 particles. Then octahedron void gives what share to each particle? Because due to these 6 particles, octahedral void is created. So octahedral void is enclosed by these 6 particles. Octahedral void is in contact with these 6 particles. So octahedral void gives what share to each particle do you say? Octahedral void gives what share to each particle? You think and say. Regarding this, you think and say the answer. Now we said this octahedral void we considered this in the octahedral void this is one layer, it is another layer opposite manner we placed, another layer opposite manner we placed. So we got a octahedron we got. So at center of this octahedral void we said, okay, now this octahedral void is in contact with the 6 constituent particles. This octahedral void is in contact with the 6 constituent particles. So octahedral void gives what share to each constituent particle do you say? Octahedral void gives what share to each constituent particle? What do you say? Here this is octahedron. This octahedron is formed due to these two layers. Due to these 6 particles we got this octahedron. That means octahedral void is in contact with these 6 particles. Octahedral void is enclosed by these 6 particles. Octahedral void is in contact with these 6 particles. Octahedral void is in contact with these 6 particles. So octahedral void gives what share to each particle of these 6? Octahedral void gives what share to each particle of these 6 particles? Shall we say each particle gets a 1/6 share from its octahedral void? So shall we say octahedral void gives a 1/6 share to each particle? Shall we say? Sir, okay. So how the octahedral void will be there in a lattice? We'll see. In a lattice, how it will be there. In a lattice, we will take one layer like this. In a lattice, we will take one layer like this. It is one layer. Okay. Then we will construct a second layer. We will construct over this. We will construct one layer. Okay. So over this, we are constructing one layer like this. In the same manner, below this, we will construct one layer, isn't it? So like this, only layers will be there. Layers will be there in the lattice. In the lattice. Okay. So it is one layer. This is one layer. So above this one layer we placed. Above this, the other is below, anyone. Now above this we are keeping one layer. Like this only we will continue, no? Like this only we will continue, isn't it? So this is one layer, this is one layer, this is one layer. So this is one layer we will consider. Above this we will keep one layer. Above this we will keep one layer. Like this only close packed arrangement will be there in HCP and FCC, no? Now you see these two are identical or not, you see. Similarly you see these two are identical or not, you see. These two are not identical. 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 Correct? So like this only we will arrange in a close packed lattice. So now we will see how the octahedral voids how each particle will be in contact with the octahedral voids will be in lattice, that we will see. So for this we will take one layer. I will take this is one layer. In this layer let me consider this yellow color particle. This yellow color particle will be in contact with how many octahedral voids in a lattice, in a close packed lattice, that we want to see it. So now this we have taken. This is this yellow color particle is in contact with how many octahedral voids, that we want to see. Okay, sir. So now we will take some particles and we will arrange octahedral voids. We will try to get octahedral voids. We will try to get octahedral voids using this. So now we have taken this. We will keep second layer particle like this. We are keeping second layer particle in this way. We are keeping a second layer particle like this. We are keeping second layer particle like this. Then we are keeping second layer particle like this. So we placed second layer particles in this way. We placed second layer particles like this. Okay, we placed second layer particles like this. What void is created? What void is created? That we will see. Now we will see what void is created. That point we have to see. So like this it is present. Like this it is present. Okay. Now below this, what void is there? Do you think? Below this, what void is there? Do you think? Below this ball. Otherwise, below this green color ball. Below this green color ball, what void is there? Do you think? So below this green color ball means this point only, no? This point only, no? Here what void you will get? You see, this point means is this void present due to these three balls? Due to these three, that means this yellow color, this front pink, this front pink. Due to these three, this triangular void is there. Over this green color ball is there. So below this green color ball, okay, below this green color ball, what void is there? What void is there? You see. What void is there? You see. Okay. So this is a pale green. It is pink. It is pink. Due to these three, here void is there. Okay, it is pale green, it is pink, it is pink. Due to these three, here void is there. Now we will keep this green color ball like this. Now below this green color ball, this void is there. No, this void is called what? That void is enclosed by how many particles do you think? This void is enclosed by how many particles? Shall we say 4 particles? This void is enclosed by 4 particles means that is called tetrahedral void. So below this green color ball, tetrahedral void is there. This pale yellow color ball is in contact with this yellow color ball is in contact with this tetrahedral void. So next we'll see this one. I'm rotating like this in order to see. So below this we will see, below this ball, below green color ball, tetrahedral void, we confirmed it. Now below this we will see. Below this what void will be there? We will see. Shall we say same like green color ball? We will confirm it. I am lifting this ball. Now this void I am taking. This void is formed by this yellow color ball, this front pink, this front pink. Due to these three means this yellow, this front pink, the front pink. Due to these three, this triangular void is created. Over this triangular void, we are keeping this particle. So below this particle, what void is created? That you see. So this void, below this particle void is there. That void is in contact with the 4 particles. So that void is called a tetrahedral void. Okay. Next, I am rotating this layer. I am rotating and I brought this. Now below this we will see. Below this we will see. Here we will see. Okay, this place we are seeing. Now this void is in contact with this yellow color, front pink, front pink. This void is in contact with this yellow color, this pink, this pink. Now we will keep this ball over this. So below this, shall we say tetrahedral void? Below this, shall we say tetrahedral void? So below this, what is there means here tetrahedral void is there. Tetrahedral void is there. Okay, so we said tetrahedral void. Okay, so now this yellow is in contact with how many tetrahedral voids? That we will see. Now here it is a first layer. In this yellow is having one void here. Okay, that void will keep to indicate that void will keep like this. So this yellow color is having one void here, second void, third void, fourth void, fifth void, sixth void. So this yellow color ball is having 6 voids here. Around these 6 voids are there. One void is here. One void is here. Second void is here. Third void is here. Fourth void. Fifth void. Sixth void. So this yellow color ball is in contact with the 6 whites. Now we will arrange the second layer. Second layer means over the void only we have to keep second layer particle. So over the void, if we keep second layer particle, then this void becomes a tetrahedral void, isn't it? Over this void, if we keep particle, over this void, if we keep second layer particle, then below this here, what void is created means, here what void is created means tetrahedral void is created, isn't it? Tetrahedral void is created. So now we will see. This yellow color ball is in contact with the 6 whites. This yellow color ball is in this yellowish green ball is in contact with the 6 whites. While you are constructing second layer, can you keep second layer particles over all these 6 whites? While constructing second layer, can you keep second layer particles over all these 6 whites? Is it possible? We will check. Over this we placed. Can we keep over this? Can we keep over this? That also will check it. Suppose we are keeping over this. Then can we keep over this? Over this can we keep? No, we can keep here only. We can keep like this only. We cannot keep over this. We can't keep over that wide. Okay. See, over this wide if we keep, over brimstick, it is brimstick. The neighboring wide is here. If we keep neighboring wide, in this broomstick is having wide, no? In that wide, over that wide, we cannot keep second layer particle. Neighbor only we can keep. Like this neighbor only. Like this neighbor only we can keep. So this broomstick is there in wide, no? Over that wide, we can't keep second layer particle. So how to keep second layer particles? How to keep second layer particles means over this wide, if we keep second layer particle, neighboring void, over neighboring void we can't keep second layer particle. So if we keep second layer particle over this void, it is neighboring void. If we keep second layer particle over this void, over this neighboring void, we cannot keep second layer particle. So successive voids cannot be placed by over successive voids we can't place second layer particles. So if we place second layer particle over this void, then neighboring void should be left. Then over this void only we can keep second layer particle. So what is the conclusion? Alternative voids will be placed second layer. So we can keep second layer particles over alternative voids, not successive voids. We can keep second layer particles over which voids means over alternative voids, but not over successive voids. That is the conclusion. So it is the first layer. So we will take suppose one layer we are taking, one layer we have taken like this. Over this we can construct second layer. How to construct second layer means over the voids only, we can construct second layer. Over which voids means over alternative voids only we can keep second layer particles. Okay, so what is the conclusive statement? We can keep particles over alternative voids. Okay, so it is one layer. If you take it is one layer. In this yellowish green is the center. This yellowish green is having six whites around it. Now over the whites we can keep another layer particles. Over which whites we can keep another layer particles? Can we keep over all the whites? Can we keep another layer particles? Can we keep over successive whites? Can we keep another layer particles? Can we keep another layer particles over alternative whites? Over which whites we can keep? That you think and say. So what is a conclusion in the sense over alternative voids only we can keep another layer particles. Over alternative voids only we can keep another layer particles. Over successive voids we cannot keep another layer particles. It is a conclusion. Sir, it is one layer. So we are constructing another layer for which we have to consider alternative voids. Sir, it is one layer. So we will consider the another layer we are considering. Over alternative voids we are keeping particles, we got another layer. Sir, now below this what void is there? Tetrahedral void. Below this what void is there? Tetrahedral void. Below this what void is there? Tetrahedral void. Then shall we say this, in this layer, this yellowish green is having 6 voids. In the 6 voids, alternative voids are occupied by another layer particles. That means 3 particles. 3 voids are occupied by another layer particles. Due to that, what void created? We said tetrahedral void. Suppose if you keep particle over this void, suppose you are keeping particle over this void, then this void will become tetrahedral void. Now we will take neighboring void. Neighboring void. We will take neighboring void. Now you say regarding this neighboring void, over this can we keep a second next layer particle? We can't. Then it is not tetrahedral void. Yes or no? Okay. Next we will go for a, this is not tetrahedral void. Okay. Next we will take this void, we will take. Now this void, over this void can we keep particle? Another layer particle? We can't. Then this void is not tetrahedral void. Sorry, okay. Then we will take alternative void, that is here. Over this we can keep, over this if we keep a particle, then it is alternative void to this. Over this alternative void we can keep particle, then this void becomes a tetrahedral void. On either side of tetrahedral void can you get a tetrahedral void? It is tetrahedral void. On either side means this side we cannot keep a, this is a tetrahedral void, this is successive void. Over this we cannot keep another layer particle, therefore it is not tetrahedral void, isn't it? So this is a successive void, over this we cannot keep another layer particle, so it is not tetrahedral void. So what is the conclusion? Now this is in contact, this is having 6 voids here like this, 6 voids. Out of 6 voids, alternative voids occupied by next layer particle, next layer particles. So this is having 6 voids. Okay, 6 voids are there. Which voids are occupied by next layer particles? Alternative voids are occupied by next layer particles. Alternative voids means 3 voids are occupied by next layer particles. So three voids are called tetrahedral voids. What about remaining 3 voids? What about remaining 3 voids? What do you say? What about remaining 3 voids? What is that remaining 3 voids? Do you think? What is that remaining 3 voids? Do you think? That we will see. Okay, it is one layer. We will construct another layer. One particle here, one particle here, one particle here. Okay. Below this, what is that? Tetrahedral void. Below this, tetrahedral void. Below this, tetrahedral void. Sir, okay. Now we will see what about this void. What about this void? We will see. What about this void? This void is which void do you say? This void is which void do you say? Okay. For which we will keep one more particle also. We will keep. Then you say that is which void that is, that you say. Sorry. So we will do one thing. That void is which void we have to say. Now these two particles, in the place of those two particles, in the place of these two particles, I will place uh, two particles like this. Okay, I placed. Now Below this we said tetrahedral void. Okay, below this we said tetrahedral void. Below this tetrahedral void is there. Below this tetrahedral void is there. Below this tetrahedral void. Below this also tetrahedral void. Now the broomstick is passing, no? Broomstick is passing now like this. Okay, broomstick is passing like this, no? Is it called a void? The broomstick is passing like this, no? See, broomstick is passing like this between two layers. Is it a void? If it is a void, what is that void called? What is that void called? Okay, what is that void called, do you say? Okay, so that broomstick we will take like this. Broomstick we have taken like this. Okay, now you see that you see it is a one layer. This yellow color ball, you see, now we will keep another layer over the alternative voids we placed. Now we will consider a void like this. We will consider a void here. We are considering a void here. Now this void is in contact with this void is in contact with how many particles? How many particles of front layer do you say? How many particles of front layer do you say? How many particles of front layer? This void. Okay, this void is in contact with how many particles of front layer, that you say. Then how many particles of front layer you say. Okay, that void, this broomstick void is there, no? That void is in contact with how many particles of front layer? Front layer means this 1 2 3, correct? Now how many particles of back layer, that will see. How many particles of back layer, that will see. Okay, you see this broomstick, you see, that is in contact with how many particles of back layer, you see? These two and this yellow, correct? This yellow and these two pink. That means this broomstick is passing through a void. That void is in contact with three particles of this layer and three particles of this layer. Three particles of this layer, isn't it? Three particles of this layer, correct? Correct. This broomstick is in contact with three particles here in this layer and three particles in this layer. Three particles in this layer. Here broomstick is there. See, this broomstick is in contact with three particles here. This broomstick is in contact with three particles here. Correct? So now you say that this broomstick is passing through a void. This broomstick is passing through a void like this. Okay, you see this broomstick is passing through the void. Okay, this broomstick is passing through the void. That void is there. That void is passing in two layers equally. Okay, so above layer void and below that below layer void, both are coinciding with each other, both are parallel to each other. Therefore this broomstick is passing. Correct? Have you got idea? Now see that we have taken this, it is above layer. Above layer void is there. Through that void I am passing this broomstick. That is passing like this. Okay, that is passing how like this. See, that is passing how it is. See, okay, that is passing how you see. Is it passing even through below layer? That means shall we say that this broomstick is passing through above void as well as below void? Shall we say this broomstick is passing through above void as well as below void? Then shall we say this void is present in above layer as well as in below layer? This void is in contact with six particles, shall we say? This void is in contact with three particles of above layer and three particles of below layer, shall we say? Shall we say this void is in contact with six particles? Six particles means due to six particles octahedron is formed, shall we say? Then shall we say this void is called octahedral void? So this void is called which void? Means octahedral void. Now you say this octahedral void, this octahedral void is this octahedral void. In this octahedral void is in contact with this yellow color particle. Okay, this yellow color particle is in contact with this octahedral void. Shall we say or not? You see, this yellow color particle is in contact with this octahedral void. Okay, this yellow color particle is in contact with the octahedral void. Have we got an idea, sir? So now we can say, we said one octahedral void, we said. Okay, so now we will think, now we will consider this is one layer. This we will keep over this layer, we will keep this layer. Below this tetrahedral void is there, that we know. Okay, next alternative. Over alternative void we placed another layer. Below this tetrahedral void is there. Over alternative void we are placing another particle for next layer. Below that tetrahedral void is there. Now below this tetrahedral void is there. Okay, below this tetrahedral void is there. Now below this tetrahedral void is there. What about this void? What about this void? What do you say? What about that void? What do you say regarding that? For that void I will keep what about this void? One more particle I will keep like this. Okay, what about that void do you say? This void is which void? Okay, so we are saying that below this tetrahedral void we are saying. Okay, below this tetrahedral void, below this tetrahedral void, below this tetrahedral void. Now what about this void? This void is which void? That void is enclosed by how many particles? That broomstick you see, back of broomstick, can you see yellow color particle? That is in first layer. So this broomstick is in contact with how many first layer particles? 3 particles. Above layer 2 particles are given here. 2 particles are given here. We can keep 1 particle here. We can keep 1 particle here. Then this broomstick void is in contact with how many particles you think it? How many particles do you say? Do you say 6 particles? If it is 6 particles, then it is octahedral void. So below this tetrahedral void, in between these two tetrahedral voids, what void is there? Shall we say octahedral void? So below this tetrahedral void we said, in between these two tetrahedral voids, what void is there? Octahedral void is there. So in between two tetrahedral voids, what is there means octahedral void is there, sir. So now we said in between two tetrahedral voids, what void is there means we said octahedral void is there, we said. Okay, so in between two tetrahedral voids, what void is there means octahedral void is there. That is the conclusion. So now we will take this. It is one layer. So in this layer, this is one layer. In this layer we will consider this yellow color. This yellow color is having how many voids means 1, 2, 3, 4, 5, 6. This yellow color is having 6 voids. Over these voids we can keep next layer. Over which voids we can keep next layer means over alternative voids. Over alternative voids only we can keep next layer. Correct? Over alternative voids only we can keep next layer. Sorry. So if suppose if you are keeping over this void, next layer you are keeping, then this void will become tetrahedral void. So now we are taking this void. Over this void we are keeping next layer, then it is becoming tetrahedral void. Next layer particle we have to keep over alternative. So over this alternative void we can keep next layer particle, then this void becomes tetrahedral void. So this is tetrahedral void, this became tetrahedral void, this also became tetrahedral void. In between these two tetrahedral voids, what about this? This we made as tetrahedral void by keeping next layer particle. This is alternative void, over this we are keeping particle, so this void becomes tetrahedral void. In between these two tetrahedral voids, this void is there. what about this void? Over this void we can't keep a second layer particle. Okay, over over this void we cannot keep a next layer particle. So what void this is? Shall we say this is called a octahedral void? So between two tetrahedral voids, between these two tetrahedral voids, what void is created means octahedral void is created. Sir. So now regarding a void, regarding tetrahedral void and octahedral void, how it is there, that we got a conclusion. Sorry, okay. So now we are taking this layer, we are taking in this layer we are taking this yellow color particle, this yellow color particle, this yellow color particle is in contact with, that yellow color particle is in contact with the 6 voids we are saying. Okay, this yellow color particle is having 6 voids we are saying. Over the voids we can keep next layer. Over which voids we can keep next layer, in the sense over alternative voids only. So over which void you are keeping the next layer particle, that void becomes tetrahedral void. Over which void you are not keeping another layer, that void is a octahedral void. That is the conclusion. So what is the conclusion here? What is the conclusion here? Over this yellow color particle is having 6 voids. Over alternative voids we can keep second layer particles. Those voids are acting as tetrahedral voids. What about rest of the voids? They will act as octahedral voids. Sir, okay. So we said regarding tetrahedral voids and octahedral voids, we said, sir, okay. Now we will take first this yellow color ball we have taken. This is what void means. This is called a tetrahedral void. Then what do you say about this? This is successive void. Shall we say this is octahedral void? Then this tetrahedral void, then this octahedral void, then this tetrahedral void, then this octahedral void. So this yellow color ball is having 6 voids, means they are successive tetrahedral and octahedral voids. One is suppose this is tetrahedral, then it's this is tetrahedral, means on either side of this tetrahedral what is there, means octahedral is there. So this is tetrahedral, means this is octahedral, and this is also octahedral. Okay, this is tetrahedral, means this will be octahedral and this also will be octahedral. Correct only, no? So that this yellow color is in contact with how many tetrahedral voids and how many octahedral voids due to the above layer, now you say, now because of, now we construct a next layer. Now in this layer, in this first layer, that yellow color ball is there, no, yellowish ball is there, no, that is in contact with how many tetrahedral voids and how many octahedral voids do you say, because of these two layers. So shall we say that yellow color ball is in contact with 4 tetrahedral voids and 3 octahedral voids? 4 tetrahedral voids. Why? Because below these 3, that means here exactly this yellow color particle surface, above, surface of this yellow color particle above, what is there, means tetrahedral void is there. That I will show you. See here, it is tetrahedral void. Okay, it is touching that first layer yellow color ball. So this yellow color ball is in contact with how many tetrahedral voids now? 4 tetrahedral voids. And how many octahedral voids? 3 octahedral voids. In the same way we will construct below one layer, we construct. Now you say, in this layer yellow color ball, this layer yellow color ball is in contact with how many tetrahedral voids totally? In this layer yellow color ball is there, no, that yellow color ball is completely enclosed. Okay, that yellow color ball is completely enclosed. That yellow color ball can't be in contact with any more particles. In this layer yellow color ball is there, that yellow color ball can't be in contact with any more balls, because already it is enclosed. Already it is enclosed. You see, that is enclosed. Okay, that is enclosed. So in this layer, yellow color ball is there. That yellow color ball is completely enclosed. Okay, so in this layer, yellow color ball is there. That yellow color ball is completely enclosed. It can't be in contact with any more particles of the lattice. So this yellow color ball is completely enclosed. It is over. So now in this layer, the yellow color ball is in contact with totally how many tetrahedral voids because of above and below layers, and how many octahedral voids. Shall we say, in this layer yellow color ball is there. That yellow color ball is in contact with 8 tetrahedral voids and 6 octahedral voids, shall we say. So in this layer yellow color ball is there. That yellow color ball is in contact with 8 tetrahedral voids and 6 octahedral voids, shall we say. So like this we will say. So in a lattice, if you take, in a lattice you are taking, in a lattice if you take each particle, now we have taken lattice. In this lattice, okay, we have taken lattice. Now in this lattice, each particle will be in contact with how many octahedral voids and how many tetrahedral voids do you say. It is a lattice. It is, lattice means contains many layers. This lattice, this layer continues in continues to infinity. It is another layer. It is another layer. Now we will keep next layer. We will keep, this is next layer. So we will go on construct like this layers. We will go on construct the layers. It will end at infinity. So if we construct like this, then shall we say each particle in a close packed lattice. Close packed lattice means either HCP or CCP. Each particle in a close packed lattice is in contact with how many tetrahedral voids and how many octahedral voids? That is the question. So it is a lattice. It is a close packed lattice. In this close packed lattice, each particle is in contact with how many octahedral voids and how many tetrahedral voids? That you see. So in a close packed lattice, each particle is in contact with how many octahedral voids and how many tetrahedral voids? Shall we conclude that each particle in a lattice is in contact with 6 octahedral voids and 8 tetrahedral voids? Okay, we will complete the class. We will continue in the tomorrow 6:30. We will continue.